Okay, so this is going to be the last lesson on how to use Desmos, and then I'm going to go over cube roots and square roots. So first, how do we type this into Desmos? Well, there's a way you can get in. There's a couple of ways, but I'll show you what I like to do. So if I want to do a square root, I do SQRT, and look what happens. It appears. So to make a square root parent function, just do that. That's what it looks like. So again, y is equal to SQRT, x shows up. Okay, so that's how you do a square root function. If you want to do any kind of root, actually, but I'm going to use it for the cube root, you do end like that. See? Watch this. It's the nth root. See? And so I can make it, I could type a 3 in here and then move my x into here. And it looks like that. Okay. So those are my two parent functions. As far as the inside-outside rules, it works exactly the same. So I'll turn this one off right here. If I want to shift this to the right, I would subtract 3 from the inside, you see. Or I could subtract 4 to move it even further. If I want to move it to the left, then what I would do is I'd actually add. So I could put plus 3 on the inside, and I get that horizontal shift to the left. Okay, so just like we saw with the absolute value and with the quadratic, we put the number on the inside. Now if I want to move it vertically, I could move it up 4 units. Whoops. There we go. Or I could move it down 4 units. So same exact rules, they all apply the inside-outside rules to these square roots. Now let's turn on our cube root down here. So you can see the cube root actually has this sort of S-type shape to it. So what I'm going to do is, again, show you if I want to shift this to the left, I could put plus 3, it moves left. If I shift it to the right, I put minus 3, and it goes to the right. Otherwise, I can put the numbers on the outside of the cube root symbol. So I have, let's say, plus 4, it moves up. If I move minus 4, it moves down. So inside-outside rules apply for both of these, okay? So let's talk about the functions themselves. So first of all, if we look at this one here, this is what I want to point out. You get these undefined things, okay? So what I'm going to put next to this actually is I'm going to do this guy, which is our quadratic function. And then let's do a table for that. Okay, so what you'll notice about this, and I'll kind of expand this out a little bit more, is if we look at these, it's almost as if they're reversed. So we've got our 0, 0, and our 1 and 1. But then look at the 2 and the 4 right here. See how they're switched? And that's why this square root function looks kind of like a parabola turned on its side. And it's because usually what happens is if we put something into the x squared right here, it becomes much larger. Whereas if we square root something, it actually has the opposite effect. So with the parabola down here, the x squared function, you put 2 in there, you get 4. You put 3 in there, you get 9. You put 4 in there, you get 16. Whereas with this look, it's actually the other way around. We put, for the inputs, we actually, so if I go up here, I could type in 16, and you can see I get a 4. I could type in 25, and then there's my 5. So when you do these square root ones, if you want to get integers, the only way to make that happen is you have to put in a perfect square. So you can see with 1, I also have that. The other thing you're going to notice a feature about these square roots is that when you have things like negatives, I can go ahead and switch this up a little bit. I could actually, I'll put negative 3 in here, negative 25. In other words, it's always going to be undefined. And that's because if you do the square root of a negative, you don't get a real number. So that is why if you look at this, the graph, it actually appears where all of the values on this graph are positives, and you don't really have any negative inputs. So that's why that is. If I get rid of that now, see if I can go down to my other one. So let's look at the cube root one really quick. Okay, so I'll do 3, put an x, whoops, put an x in there, and then y equals. Okay. So this actually has a lot of things in common with the square root one, but you'll also notice that it does have some values over here on the left, and that is because you can cube root a negative number. For example, -1 times -1 times -1 is -1, so that's why it actually it'll work out. So you'll have a line down here. That's one way it's different. The other way it's different is the values are much larger because now we're cubing things. So you can see if I actually put in 27 here, I only actually get 3. So it means I'm all the way down over here. If I zero this out, you can see that's how far over it takes to get 3. So it actually flattens out a lot sooner than the square root. But the main way you tell them apart is that the cube root kind of has an S shape and the square root has sort of this half of parabola type thing. And before I go today, what I wanted to do is just go over one more thing, and that's like what happens if you do two things. And so far we've done things where there's just a vertical shift, or a horizontal shift, and then sometimes we mix that with a reflection, which means you turn it upside down. But let's talk really quick about like how that all works if I do two things. So what I'm going to do is I'm going to work with my parabola here. Okay, so there it is. There's my parent function. So what I've been doing so far is just sort of things like this, where I maybe shift it over, or I'm sorry, up like that, or maybe this kind of thing where I'm moving it to the right or to the left. That's what we've done so far. But what happens if I actually do two things? So here I have it moved to the right, and then if I put an outside number, you can see what happens. Okay, so look at the relationship between the vertex and what the rule is. So you can see that the y number matches this. So there's my y, which is 4, and my x is the opposite of that. Okay, so let's try it with a absolute value one. So what I'm going to do is I'm going to turn the absolute value upside down, make it look really weird, and I'm going to put a +5 in here, and then I'm going to put a -1. So let's look at the vertex for that guy. So as you can see, my y coordinate on that vertex is -1, and it matches my outside number, and my x coordinate is -5, which is the opposite of this. Okay, so usually this is going to be associated later. I don't know if you'll get to it by the end of the algebra class, but it'll definitely show up in algebra 2. It talks about hk, and so it's always -h comma k, and these numbers definitely have an importance with the function. You can see I can also do it maybe with a square root one. So I'll put x in there. So let's put something inside there. Let's put like, we'll put +1, and then I'll do minus, whoops, I gotta get it on the outside, -3. Okay, so here it is right here, and then there you can see it. You can see my y is exactly the same, it's -3, and then you can see that the x coordinate is actually the opposite of what's on the inside. So if you look at these functions and you see that they're moved around off the axis like that, you just apply the same rules, the inside-outside rules. The inside is sort of your x coordinate, and the outside is your y coordinate. So play around a bit with that. A good idea is to kind of just start like typing things in and kind of see what you get. And you'll figure this out pretty easy. So you can see here, it's actually 0, 3. And the reason is because my y is 3. And there is no x because you'll notice it's not on the inside, it's just x by itself. So that's why it's just 0. Okay.